That sound isn't a wolf. It isn't an owl. It's this, the southern grasshopper mouse, Onychomyas torridus. It stands on its hind legs, points its tiny nose to the sky, and howls. Why would an animal so small, a creature we associate with quiet scurrying and hiding, evolve to scream at the moon? The answer begins not with the sound, but with what it eats. The howl is a warning, because this is not a meek herbivore. This mouse is an apex predator in its weight class, a relentless carnivore. It actively stalks and consumes bark scorpions, giant centipedes, and even other rodents. In the brutal calculus of desert survival, it possesses a biological trump card. It can be stung repeatedly by a scorpion whose venom would induce excruciating pain and death in another mouse, and it simply attacks harder. A scorpion's neurotoxin is a master key, designed to unlock pain receptors and flood an animal's brain with agony. Specifically, it forces open sodium ion channels in nerve cells. Imagine millions of tiny doors being jammed open, creating a constant, overwhelming electrical storm that the brain interprets as pure pain. The grasshopper mouse, however, evolved a different lock. 2-minute mutations in a specific pain channel protein, NaV1.8, cause the toxin to bind in a way that blocks the channel instead of opening it. The pain signal is not just ignored, it's prevented from ever being sent. The scorpion's greatest weapon becomes a local anesthetic. This immunity to pain makes it an exceptionally successful hunter, which allows it to hold a territory. This brings us back to the howl. The sound is an advertisement of this success, a broadcast of dominance. It's a low-frequency signal for its size, which travels farther across the open desert with less degradation. By standing tall and pointing its nose to the sky, the mouse is doing exactly what a sound engineer would recommend, aiming its broadcast away from ground-level obstructions to maximize range. It is a clear acoustic fence line defining its territory to rivals miles away. How can another mouse trust that this howl represents a genuine threat? In evolutionary biology, this is the problem of the honest signal. The howl is honest because it is costly. It consumes significant metabolic energy. And, more importantly, it announces the howler's precise location to every larger predator in the area, like an owl or a coyote. To howl is to gamble. Only a mouse that is truly strong, well-fed, and capable of defending itself against both rivals and predators can afford to make such a loud, risky statement. A weaker, bluffing mouse would simply be ringing a dinner bell for a hawk. Is this complex vocalization something the mouse learns? Almost certainly not. The ability to imitate new sounds, called vocal learning, is exceptionally rare in mammals. Humans are vocal learners. So are bats, elephants, seals, and dolphins. But your dog is not. A cat is not. Even chimpanzees, our closest living relatives, cannot learn to produce new vocalizations. They are born with a fixed repertoire. The grasshopper mouse's howl is likely an innate, genetically hardwired behavior, an acoustic fossil preserved perfectly through generations because it works. The physical ability to produce any sound is governed by anatomy. In your own throat, there is a U-shaped bone called the hyoid. It's unique. It is the only bone in your body that does not directly connect to any other bone. It floats, anchored by a complex web of muscles and ligaments. This bone's position and the muscles attached to it are critical for shaping your voice. The grasshopper mouse possesses its own vocal toolkit, a tiny larynx, resonating chambers, and musculature, all precisely evolved to produce one specific powerful sound. It is a biological instrument designed for a single song. So when you hear that high-pitched, lonely cry echoing across the desert, you're hearing the culmination of millions of years of evolution. You are hearing a genetic mutation that turned a neurotoxin into a painkiller. You're hearing a high-stakes broadcast of fitness, a territorial claim backed by the threat of violence. And you are hearing a solution to the physics of sound propagation. A howl from a mouse is not just a howl. It is a story of survival written in sound. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.